Hi there again, friends and neighbors. I'm going to pick up where we left off with the last 4 questions of this quarter's example of Real Data Homework 3. Now, this is one particular quarter, and so every quarter the answers are going to be different, and so this video is not going to have the exact answers for you. In fact, even the exact questions might not be the same, but the steps are identical. Okay, and I've already loaded R Commander EZR, and imported the data file, so I'm ready to go. Next, I need to find the spread. We already found the shape and center. We're finding the spread. We're going to do the range, the IQR, and the sample standard deviation. So the range, that's the maximum minus the minimum. I've got the 5-number summary here, so the maximum is 77, and the minimum is 5.4. We can go to any calculator that we like to do that. I'm just going to do it here in R, but you can do it in Excel or any spreadsheet you like or any calculator that you like. So 77 minus 5.4 gives me 71.6, and that's the range. The IQR, or interquartile range, is Q3, the third quartile, 75th percentile, minus Q1, the first quartile, 25th percentile. That's 70 minus 64, which of course is 6. 70 minus 64 is still 6. So the IQR is 6. The sample standard deviation is given as 9.757. Rounded to one place, that is 9.8. The next question has self-explanatory instructions. What it essentially says is, when you don't know what the actual standard deviation is, which is sometimes the case, you can take the range and divide it by 4, and it should be a pretty good approximation. Not always, but often it's a pretty good approximation. Let's find out if that's true this time. Let's compute the range rule of thumb. 71.6 divided by 4. 71.6 divided by 4 gives me 17.9. So the range rule of thumb is 17.9. Is that close to the actual sample standard deviation? Well, no. 9.8 is the actual sample standard deviation. I think that's pretty small. In fact, I think that's much smaller than the range rule of thumb. So now I click Submit if I wanted credit for it, which of course I do not. And that's the spread. So we've done shape by making 2 graphs and describing them, center by median and mean, and spread. Now we're going to talk about outliers, extremities. So I'm going to move on to the 6th question, question 1F. So a student says their height is 82 inches. Compute a z-score, rounding to one place. So the mean is 65.7, we remember that, and the standard deviation is 9.8. So the z-score is x minus the mean divided by the standard deviation, or 82 minus 65.7 divided by 9.8, which gives me a z-score of 1.66, rounded to one place, that's 1.7. Now that's not considered an extreme value because extreme values are z-scores that are bigger than 2 or smaller than -2, so that's about right. Click Submit and move on, except I'm not going to do that. So I'm going to go instead to homework question 7, which is 1G. Another way of defining IQR is to compute the fences. Q3 minus 1, outliers is to compute the fences. Q3 minus 1.5 IQR. I'm sorry, Q3 minus plus 1.5 IQR is the upper fence, and the lower fence is Q1 minus 1.5 IQR. So let's compute those fences. You recall the IQR is 6. So let's find out what the lower fence is. Let's see. Q3 is Q1 is 64. So I'm going to do 64 minus 1.5 times 6. Then the upper fence is Q3, 70, plus 1.5 times the IQR, which is 6. So let's compute those two numbers. They are 55 and 79. Okay. Using this definition, is 82 an outlier? Any number bigger than 79 would be an outlier, and any number smaller than 55 would be an outlier. Since 82 is bigger, that means it is unusually large. In this case, do the two rules agree? Well, the z-score, if you might recall, for 82 was 1.7. It was not considered extreme. So 82 is an outlier using IQR, but not using z-scores. That's going to happen sometimes. That's part of the point of this lesson. They don't always agree. Sometimes they do, and sometimes they don't. Sometimes one is considered large and the other is considered normal. Sometimes one is small and the other is normal, and it just fluctuates. They're actually asking somewhat different questions. IQR is based on rank. Standard deviation is based on arithmetic. Okay, last question. This is about the empirical rule. So if the variable is approximately normally distributed, then we can use the empirical rule. So I'm going to get the z-score for 56 and for 86. Okay. So for 56, we say 56 minus the mean of 65.7 divided by the standard deviation of 9.8. And for 86, we say 86 minus 65.7 divided by the standard deviation of 9.8. And get these two z-scores. Boom and boom. So negative 0.989, which to one decimal place would be negative 1, and positive 2.1, which is pretty close to 2. So, what area under the curve is that? Looking at the empirical rule, that's the area between one z-score below, a z-score of negative 1 and a z-score of positive 2. So 68% of the curve is between negative 1 and positive 1. 95% of the curve is between negative 2 and positive 2. What we're doing is a z-score from negative 1 to 0, which has a 32% area, and a z-score from 0 to 2, which has half of 95%. Okay? Half of 95 is 47.5. So essentially what I'm doing is half of 68 plus half of 95. That's what I'll do. 68 over 2 plus 95 over 2. And that gives me 81.5. I click submit, and that's all. Alright, hope you enjoyed that video. We'll talk some more later.